Hey everyone, so in this video I'm going to be going over an example of a Ferris wheel in which we've incorporated the variable of time into the situation. So the first thing we're going to do is fill in the missing times and the heights on the wheel. So in order to do that, we need to make sure we look at the important information about the Ferris wheel. So we know the center of the wheel is 46 feet off the ground. The radius of the wheel is 39 feet. It takes 100 seconds to go a full rotation around the wheel. The wheel is rotating counterclockwise, which it always is, starting on the far right where the basket is. That's also always the case. The other three pieces of information are what we see changing most of the time. So I'm going to start by filling in the missing time. So it takes 100 seconds to do a full rotation. So I'm going to put 100 over on the right because that's where we start and end. So we could also write 0 seconds up here if that helps you remember that's where we're starting. But also when we finish the rotation, it'll be 100 seconds have gone by. So to find the rest of the times, I need to take my total time and divide it into 4 because we have each point at each quarter on the wheel that we're trying to find the time for. So 100 divided by 4 gives me 25 seconds in each quarter of the wheel. So that means to go from the starting point to the top is going to be 25 seconds. Then to go from the top to the leftmost point is 25 more seconds. So 50 seconds. To get to the bottom is 25 more seconds. So 75 seconds. So to go all the way around the wheel, 25, 50, 75, 100. You're just counting by whatever number you get when you divide the total time by 4. Now to do the heights, we'll start with the left and right points because these are at the same height as the center. And the center is 46 feet off the ground. So that means the farthest left and right points on the wheel are also 46 feet off the ground. To get the highest height, the highest point, we need to add the center of the wheel plus the radius. So 46 plus 39, which is going to give me 85 feet. I believe I can double check that. 46 plus 39, yes, gives me 85. And then to get the lowest height on the wheel, I'm going to subtract 46 minus 39, which gives me 7 feet. And I've gone over why that is in another video. So we should be good with that by now. Okay, the next question says, after 55 seconds, will the rider be above or below 46 feet? So I need to figure out where on the wheel we would be at 55 seconds. So it takes 25 to get to the top, 50 to go halfway. So 55 is going to be a little bit past the halfway point. I'm going to just draw it like here. This is just an estimate of where 55 seconds would be. And we can see that at 55 seconds, they've gone past halfway, so they're below the center. So since the center is 46 feet off the ground, they're below 46 feet. So the rider would be below 46 feet because it takes 50 seconds to go halfway. So 55 seconds is a little past halfway. A little below the center. And you can explain that in whatever way makes the most sense to you, but something along these lines is good. Okay. Now it says name a time when the rider will be above 46 feet and how do you know? So your answer could definitely vary for this. If I want to name a time when the rider will be above 46 feet, I'm going to need to name a time in the top half of the wheel that would fall in the top half of the wheel. So for the first time the rider goes around, they're starting at 0 seconds and they hit the halfway point at 50. So I need to pick a number that's above 0 but below 50 so that they're in the top half of the wheel, which would be above 46 feet. So, for example, I could pick 23 seconds if I wanted to. So 23 seconds. At 23 seconds, the rider is almost to the top of the wheel. So they are above the center, which is 46 feet. So you could really pick any time that is between 0 and 50 and just explain that wherever that time is, explain where it is, and that since it's above the center, it's going to be above 46 feet. The next part says, write a function h of t that can be used to determine the rider's height at any time t. So we should know by now, I'm going to remind you, our format for these equations. So we always have the radius, I'm going to write it down here, times sine of an angle, or angle of rotation, plus the height of the center. Now the difference here is that we want this to be based on time, not based on theta. So we're not, instead of putting theta inside of sine, we're going to be putting the degree of rotation times the time. So times t. That's what's going to go inside of sine, because we learned that when we want the equation to be based on time, if someone gives us a time, the first thing we have to do is convert it into an angle by multiplying by the degrees of rotation and then plugging that into sine. So the first thing I'm going to do is find the degree of rotation by doing 360 degrees. And that's my total degrees divided by the time it takes to go all the way around, so 100. And 360 divided by 100, let's double check, but I think it should give us 3.6 degrees per second. So now I can write my equation. H of t equals my radius, which is 39, times sine of my degrees per second, 3.6 times t, plus the height of the center, 46. And so now the next question says, how high off the ground will the rider be after 73 seconds? So we want to find the exact answer using the equation. And then we're going to make sure our answer makes sense using what we know about the wheel so far. So 73 seconds, that just means I want to plug in 73 to the equation I just wrote. So I'm going to replace t with 73. And I'm going to use the Desmos scientific calculator for this. So 39 times sine of 3.6 times 73 plus 46. We'll see if I remember. 39 times sine of 3.6 times 73, and it's in degree mode, plus 46. Gives me 7.31 feet if I'm rounding. 7.31 feet. And now I want to think if that makes sense. So where would I be on the wheel at 73 seconds? 73 seconds would be, so it takes 75 to get to the bottom. So 73 would be just before we get to the bottom. 73 seconds. So if it's just before the bottom is 7 feet off the ground. So I'm going to be a little above 7 feet off the ground. So my answer actually makes exact sense because my answer was a little above 7, so 7.31. So yes, 73 seconds is almost to the bottom, which is 7 feet. So it should be a little above 7 feet. Okay. So between all those questions, you should be prepared to do your practice and prepare for your quiz. So hopefully that helps.